Okay, let's get started. As you know, today I promised to take you on a walk through the solar system. So let's start here with the central object of our solar system, the Sun. As you can see, the Sun is about 5 inches in diameter, and that's about the size of a large grapefruit, which is exactly what I've used to represent it here in our model. So I'm going to take two steps, and that will bring me to the planet closest to the Sun. That would be Mercury. Two more steps to Venus, and one step from Venus to Earth. Let's continue walking with three steps from Earth to Mars. And that's as far as I can go here in the classroom, but we can visualize the rest of the journey. Don't bother writing this down, just stay with me on this. So, to go from the Mars to Jupiter, we have to walk a little over half the length of a football field, so that we would have about an arrival here on campus. And then, to get from Jupiter to Saturn, we have to walk about 70 high road. So by then, we'll be at Hammond Hall. From Saturn to Uranus, we'll have to walk again as far as we've gone in our journey from the Sun to Saturn. And so we'll probably be at the Student Union. From Uranus to Neptune, we'll have to walk the same distance again, which would take us all the way to the graduate dormitories from Neptune to Pluto, another 125 years. So we'd end up about one third of a mile from this classroom at the entrance of the Crown campus. Okay, that's interesting, but now I want you to think about the orbits of the planets in those locations. Clearly, the first four planets could orbit fairly comfortably in this room, but to include the others, we'd have occupied area of more than 6/10 of a mile, which is all the way from Cutlery Avenue to Campus Drive. Remember that for this scale, the Sun is 5 inches, and most of the planets are smaller than the lead on a sharpened pencil. Okay, with that in mind, I want you to think about space. Sure, there are some moons or a few planets and a scattering of stars and comets, but really, there isn't a lot out there in such a vast area. Well, it's pretty empty, and that's what I really want to demonstrate with this exercise. Now, it would really be even more impressive if you could actually make that work, and actually you can. You could visit Washington D.C. where a scale model is set up on the National Mall, starting at the National Air and Space Museum and ending up at the Industry Museum. I did it a couple of years ago, and it was, well, amazing. Even though I knew the distance intellectually, there's nothing like the experiences. Has anybody else done that walk? I have. And you're right, it's a night opener. It took me about 20 minutes to go from the Sun to Pluto because I started to read the information to its planet, but I made it was about 10 minutes. Did you take pictures? I didn't. But I don't think it had captured it anyway. I think you're right. What impressed me about doing it was to see what was not there. I mean, how much space was between the bodies in the solar system, and a photograph wouldn't have shown that. So back to our model. Here's another thought for you. The scale for our model is 1 to 10 billion. Now let's suppose that we want to go to the nearest Celsius as a neighbor to our solar system. That would be our central system. Okay, let's walk it on our model. Here we are on the east coast of the United States, so if we want to make it all the way Alpha Centauri, we have to always go roughly a distance of 2,700 miles, and that's just the closest one. To make a model of Milky Way galaxy, it would require a completely different scale because the surface of the Earth would be large enough to accommodate a model at the scale of 1 to 10 billion. Now, let's stop here for a minute because I just want to be sure that we're all together on the term solar system and galaxy. Remember that our solar system is a single star, the Sun, with various bodies orbiting around it, 9 planets and their moons and asteroids, comets, meteors. But the galaxy has a lot of star systems, probably 100 billion of them, okay? This is important because you can be off by almost 100 billion if you get confused by these terms. Not a good idea. Okay then. Even if we figure out a different scale that would let us make a model of the Milky Way galaxy, even then, it will be challenging to make 100 billion stars, which is what you have to do, complete the model. How many would that be exactly? Well, just try to count all the grains of sand or which on us. That would be 100 billion. But of course, you couldn't be even in your right time, could you? If you started counting in 1000 BCE, you'll be finished just about now with the counting, I mean. That assumes that you wouldn't sleep or take any breaks. So what I am hoping for from this lecture, what do you think I want you to remember? Well, for one thing, the enormous distances and vast emptiness in space. That's good. I hope that you'll also begin to appreciate the fact that the Earth isn't the center of the universe. Our planet, although it's very beautiful and unique, it's still just one planet orbiting around just one star in just one galaxy. Galaxy.